Well, for the first questions, according to the formula, we can know that the mean of zt equals this part, and because the mean is linear and the n1t, n2t, and the theta are all independent to each other, so that we can rewrite the mean of zt into this part. And because n1t and n2t are y-distance stationary, so according to the definition of y-distance stationary, we know that the mean of n1t and the mean of n2t should both equals to a constant, so that we assume that the mean of n1t equals eta 1, the mean of n2t equals eta 2, so that the mean of zt equals eta 1 multiply this part minus the product of eta 2 and this part. And according to the definition, we know we can calculate that the mean of cosine omega c t plus theta should equals 0, because theta is from 0 to 2 pi, and the same, the mean of this part should also be 0, so that the mean of zt equals 0. And the second, if zt is y-distance stationary, it should satisfy two conditions. The condition 1 is that the mean of zt is a constant, which we know that from the first question zt satisfy this condition. And the condition 2 is that the autocorrelation of z is only dependent on tau and has nothing to do with t, so that we should see if the autocorrelation of tau satisfy this condition. And the autocorrelation of z equals this part according to the formula. And in this case, we can see that the autocorrelation of z equals this part, and we can consider them separately because they are linear. So we assume this is part 1, this is part 2, this is part 3, and this is part 4, so that the autocorrelation of z equals the mean of part 1 minus the mean of part 2 minus the mean of part 3, and add the mean of part 2. So first, for the part 1, we can know that the mean of part 1 equals this one. And after some steps of calculation, we can see the mean of part 1 equals this part, because n1t, n2t, and theta are independent, so that it equals the product of these two means. And we can know that the mean of n1t plus tau multiply n1t should equals the autocorrelation of n1 according to the formula. And here we should use some formulas in trigonometric function, which is we should change the product into the sum, and that is cosine alpha multiply cosine b equals half of the sum of the cosine alpha add b add the cosine alpha of cosine of alpha minus b, so that according to this formula, we can rewrite this part into the sum of these two parts. And we can know from the first question that the mean of this part equals 0, and this part cosine omega c multiply tau, and it has nothing to do with the variable theta. So the mean of these two parts equals the mean of this part and add this part, because we can see it as a constant. So as a result, the mean of part 1 should equals this part. And for the part 2, part 2, the mean of part 2 equals this one, and we can rewrite into this one because N1t, N2t, and theta are all independent, and we know that this one is the mean of N1t, and it equals to a constant with eta 1, and this part also equals to a constant because N2t is wide since stationary, so we assume it equals to eta 2. And for this part, we can also use something about the trigonometric function, which is we change the product into the sum, and that is sine alpha multiplies cosine beta equals half of the sine alpha add beta add sine alpha minus beta, so that we can rewrite the mean of part 2 into this one. And also sine omega c tau has nothing to do with the variable theta, so we can see it as a constant. And so the mean of this part should equals the mean of this part plus sine omega c tau, and the mean of this part equals 0, so that the mean of this part should equals sine omega c tau, and so that the mean of part 2 should equals this one. And for part 3 is exactly the same as part 2, and we can use the same method to deal with part 3. That is, we can know the mean of part 3 equals this one. As for the part 4 is just the same as part 1, so we can use the same method that we deal with the part 1. And we know that the mean of part 4 should equals this one. And so that the autocorrelation of z equals the mean of part 1 minus the mean of part 2 minus the mean of part 3 plus the mean of part 4, which should equals this part. So that we can easily see that the autocorrelation of z is only related to tau, and these two parts are just constants, and omega c is we can see it as a constant, so it only relies on tau, has nothing to do with t, so that we can see zt is wide since stationary. And for the third questions, we can just change the tau into 0 and put it into this equation, and we know the result should equals this part.